So welcome back. Welcome back to our lesson. We have already discussed about the function of air and alcohol vapor, where alcohol vapor is saturated and therefore it prevents the evaporation of the alcohol. Mercury. What's the function of mercury? Mercury is used to push the indices to the maximum or minimum temperature. We have seen that when the alcohol expands in the bulb, it pushes the mercury, and then the mercury in turn pushes the index to get the maximum temperature. And when the alcohol contracts, then it retreats back, and the mercury is also pushed back, pushing the index B to read the minimum temperature. So we can see that the work of mercury is simply to push the indices so that we get the temperatures that are required for that day. Alcohol is to expand or contract during the temperature rise or fall. So when there is a temperature rise, alcohol will expand in the bulb. When there is a temperature fall, the alcohol will then contract. So it is the alcohol that detects the temperature of the day, so that it expands or contracts. And therefore, those are the functions of how 6 is maximum and minimum temperature and thermometer works. So we want to look at another type of a thermometer, the bimetallic thermometer. The bimetallic thermometer. This thermometer is not one of those liquid in glass thermometers, but it also uses thermometric expansion. It uses the thermal expansion for its work, for it to function. A bimetallic thermometer looks like this. It is having two metals made in a spiral or curled together in such a manner that the two metals have different linear expansivities. So each one of those metals has its own linear expansivity. The linear expansivities of those two metals differ, and particularly the one which is outside the curve has a higher linear expansivity than the one inside the curve. So an increase in temperature causes an equal expansion of the two metals in the bimetallic strips due to their difference in linear expansivity. So when there is an increase in temperature, it causes that an equal expansion of the metals in the bimetallic strip. And the reason is because of their difference in linear expansivity. So the metal on the outer side of the curve expands more. The metal on the outer side of the curve expands more. So the increase in temperature will make that metal expand more, and this makes the spiral to curl in a clockwise direction, as we have seen it in the diagram. So it makes it curl in the clockwise direction, forcing the pointer to move over the calibration scale. So you can easily read the scale when the pointer moves over. You can read the scale, on the scale, the temperature that has been recorded. A bimetallic strip thermometer has its own advantages. Where a liquid in glass cannot be used, a bimetallic thermometer can be used. For example, a bimetallic thermometer can be used to record, or it can be used where temperatures are very, very high, to measure very high temperatures, like in an oven, for example. In an oven, you can use a bimetallic thermometer, where the liquid, a liquid in glass thermometer cannot be used, because the liquid in glass reaches a point where it can evaporate or vaporize. So when we have it at very high temperatures, the liquid in glass can vaporize. So where it cannot be used, we can use a bimetallic thermometer, so that a bimetallic thermometer is just a matter of their metals expanding at different rates, and therefore you can easily get even very high temperatures inside an oven. So that is an advantage of a bimetallic thermometer over a liquid in glass thermometer. Now, we have questions like these ones. These are the questions that we may meet. For example, if you have a question like this is just an example I'm giving. The figure 4 shows a bimetallic thermometer. So this is the figure. It shows a bimetallic thermometer. This bimetallic thermometer has a pointer, has a scale, and it has also has a pulley and a spring. So the question is, explain how a rise in temperature causes the pointer to move in the direction shown. In the direction shown. Explain how a rise in temperature causes the pointer to move in the direction shown. The direction shown here is this one. So the scale will move that way. A rise in temperature will make this pointer move on the clockwise direction. So that's the direction that we are told to explain when there is a rise in temperature. So how do we explain it? How do we explain it? The explanation is like this. An increase in temperature causes an equal expansion of the metals in the bimetallic strip due to difference in linear expansivity. So an increase in temperature causes an equal expansion of the metals in the bimetallic strip due to difference in linear expansivity. The outer metal expands more. The outer metal expands more than the inner metal. This makes the spiral to curl in the clockwise direction, forcing the pointer to move over the calibrated scale and show us the reading. So with this, I'm sure that we can explain anything that we have in the thermal expansion, in the topic of thermal expansion. We can also explain their application in terms of expanding, in terms of cooling. Like for example, when we looked at the gaps made in a railway line, the gaps are left so that there can be allowance for expansion. The loops or the loose hanging of the electric wires, those electric wires are left loose like that so that there is an allowance for contraction. And so we can explain all that. And now we have looked at how all this can be applied in measuring the temperature. Measuring temperature, we have those two types of thermometers, the liquid in glass thermometer and the bimetallic thermometer. So we will stop there, and this is the end of this topic. Maybe next time we'll be looking at another topic so that we continue getting knowledge. So thank you, and be keen to meet in the Google Classroom for some questions that will be there. Thank you.